easily. So what I do before mixing directly with my signal, I'm going to pass the signal to a low frequency LPF and HPF, low pass filter and high pass filter. So, but the IF spectrum in low frequency may extend to zero frequency, making it impossible to achieve a high IRR. All our aim is to achieve a very high rejection ratio so that my signal is effectively free from image. So in the previous Hartley architecture you have seen, you will be directly mixing the RF with your LOs. But here you see, before mixing RF with your LO, I'm going to subject the same signal to low pass filter and high pass filter. And then I'm going to mix and then I'm going to filter. So this is going to be my quadrature. This is going to be my in phase. So then if you add both, you'll get back your IF output. So this implementing RC and CR network is going to be a very crucial thing for your low IF receivers. One possible remedy is to move the 90-degree phase shift in the RP architecture. In the quadrature path, we had this 90-degree phase shift, right? So I'm going to remove that and I'm going to have LPF on both the sides and I'm going to have low pass filtering and high pass filtering on both the sides, so that I have a uniform symmetrical architecture on the both sides of your low IF receiver. Okay, so I'm going to use the same Hartley architecture for low IF receiver. Only one difference I'm going to have in Hartley architecture. After this, in the upper path, I'll have 90-degree phase shifter block, and then only I'm going to add my signal. That 90-degree phase shifter block is going to be removed here, and I'm going to add my signals directly, and then I'm going to filter the signals before I'm going to pass it to the mixing circuit. Okay, so this is going to be the architecture for low IF receiver. Remember, the idea is coming from Hartley architecture only. So both the architectures will multiply the quadrature components. We have both IE channel and Q channel, and both signal and image will be undergoing the same operation. But when you add, finally, the image will be cancelled out and the signal will be doubled. So that is the output of the low IF receiver. And it will also ensure, since in Hartley oscillator we have very high image rejection ratio, the image will be effectively cancelled at the final IF output of the low IF receiver. So one small variation of a low IF receiver is going to be using a digital. So we are going to do it in digital domain. So same thing, instead of having a low pass filter and high pass filter, I'm going to mix it directly and I'm going to pass the output to an ADC. I'm going to shift the output of the upper path by 90 and I'm going to take the lower path as it is and I'm going to add. That is going to be giving an even more effective result, and the results are digitized. So when your digital domain, I'm going to perform the summation. So they say that it is going to make my image cancellation even more perfect. And it all depends on how good is your ADC, what is the accuracy, what is the resolution, or how many number of bits I'm going to use. All these things will determine the accuracy of your low IF receiver. So avoiding in this, once you convert to digital, shifting by 90 degrees is going to be in analog domain is difficult, but digital it is going to be very easy. So ADCs should have a very large amount of bandwidth to work because our signal will be in a high frequency domain, and also they will consume high power also. And this issue is unimportant in narrow channel standards GSM because ADC power dissipation is a small fraction of overall system. You know that entire receiver is consume a lot of power, and in that ADC will consume only a very reasonable amount of power. So that is okay for me as long as image rejection is going to happen perfectly. I am okay with the minimal amount of power spent by your ADC units, which are present on both sides of your architecture. And if you compare this with your Hartley, this is the exact form of Hartley oscillator. Only thing, before the phase shifter, I'll be having ADC. But previously, we will not having ADC. We were adding everything in analog domain. But here, I'm going to convert that to digital domain, and then I'm going to add. So this is going to be the logic of low IF receiver, and it can be extended to any down conversion, and IF signal is going to have a significantly higher bandwidth. And if you want to even more reduce the burden of ADC, as told before the mixing, you employ one high pass filter and one low pass filter so that the burden on ADC is going to be reduced. So these in this image is no longer near to the adjacent channel, so a very high IRR is possible for this circuit. It is going to reject the image with a very high supremacy. Such receivers are also called as polyphase filters. So these are called as polyphase filters, and they are going to have very high image rejection